Do you know how we can store value in our computer memory? If you don't have any idea on it, then in this lecture I will teach you how to do it. Everyone, hello and welcome back. I am Aman, and in this lecture we will learn how we can store data or value in our computer memory. So here is our outline. We will learn what variables are and why we need variables in almost every programming language. Following that, we will learn how to declare variables in C programming language, how to initialize variables in C, and finally, we will look at some programming examples to help you understand variables in detail. Let's get started. Do you know how our mother keeps salt in her home? They keep salt in a box or in a plastic. Similarly, if we need to store data or value in our computer memory, we need a box that can hold that data. So we can reserve some space, and a variable is used to accomplish this task. So a variable is nothing but a box or a container that is capable of holding data. And each variable has a specific type. This is referred to as a variable because the value stored within it. It can change. Let's take a look at computer memory now. You can imagine that this table is our computer's memory. So it is divided into boxes. As you can see here, this box we have some data, which is number 5. Here we have a string that is hello, and here we have a number. So there are 3 boxes are variables. They are containers in our computer memory. You don't have to worry about where your value is stored in memory. Your task is simply to provide the name, which will internally point some memory location. Now let me tell you one thing, in computer memory each variable has a unique address. So suppose 1001 is the address of this variable, 1010 is the address of this variable, and 1101 is the address of this one. The address of each variable is actually written in a hexadecimal form, but we wrote in a decimal form for simplicity. The address specifies where the variable is located in computer memories. In reality, variables are simply names that point to some memory location. But there is one more thing that you need to be sure about. You must have to declare variable before using in your program. What does declaring a variable mean? Declaring a variable simply means telling the compiler about its property. Here, properties are that what will be the size of that variable and what will be the name of that variable. Don't worry, this is not a very difficult task. In a moment, you will see how simple it is to declare a variable. There is one more term called definition of a variable, which means allocating memory to a variable. Most of the time, declaration and definition will be done at the same time. However, this is not always the case. It depends on the modifiers that you had mentioned with variables. We will discuss modifiers later, as well as how declaration and definition is different for different modifiers. Let me demonstrate how to declare a variable. The variable's name is var in our case, and it has integer data type. Data type simply means how much space a variable is going to occupy in our computer memory. Therefore, by writing int var, you are declaring a variable and requesting that the compiler allocate memory for this variable. Please keep in mind that int var, we put a semicolon here. This is very important because this is how your compiler separates one statement from other. So don't forget to add a semicolon at the end of the variable. Now, syntax of declaring a variable looks like this: data type, variable name, and a semicolon. You don't need to worry about data type right now. We will cover it later. Now, memory space depends upon the type or data type you use. Here, because in our example, we are using integer data type. Therefore, it may take either 2 bytes of memory or maybe 4 bytes of memory. It purely depends on the system you are working on. Again, you don't need to worry about how much space is allocated to your variable. You only need to focus on variable's declaration and definition. When we assign a value to a variable at the time of declaration itself, then this thing is called as initialization. And this is how you will do initialization. Note, initialization of variable doesn't mean that you cannot change the value of this variable afterwards in your code. If you want to change this value somewhere, then you can do that. This clearly captures the meaning of a variable. Now let's see some programming examples how to use variables in our program. In the first line, we write #include. This is our header file because we need to print some value. After that, we declare the main function. Inside the main function, we declare a variable that name is var. Now suppose I initialize it first to 5. Now let's print the value of var. Now we write printf function. Inside the parenthesis, we wrote %d and we print the value. I will explain more about what this %d means. For now, I can only tell you that this will print the content of whatever is there inside this variable var. You have to put a semicolon at the end, return 0. Now press Ctrl+S to save this code and compile and run the code. For use, Ctrl+Alt+N. Shortcut key. You can see the output here, which is 5. See what will happen when the compiler comes to this line. When the compiler will see the printf function, it will search for the double quote, and the double quote is here. Now the compiler will go inside this double quote and it will show the %d. %d is a format specifier for integer value. Format specifier defines the type of data to be printed on the standard output or console window. Now the compiler will go outside the double quote and search for the comma. And the comma is here in our case. Now it will search for the first variable name after comma, and in our case we have only one variable. Now it will go to that place where this variable is declared. And here is the place where the var variable is declared. Now what is the value that is assigned to this variable? It will print on the monitor or on the console window. So what this printf function will do is print the value that is assigned to this variable var. Now let's take another example where we change the value of variable var. Let me change the code first. Inside the main function, I am first declaring a variable whose name is var. Suppose I initialize first to 5 and afterwards I change this value to 10. You can observe that I had not written int var again in this statement when I am assigning value to it. Because the memory allocated to a variable once and defining it once again means you want to allocate memory again for the same name. And this is not valid. Note, each variable must be defined only once in a function or a block, but it can be used multiple times with different assignments in your program. Print the value of var, save and run the code. You can see the output here, which is now 10. Previously I had initialized the value, which is 5. And then I change the value, which is 10, and after that print the value of var, and as expected my output is 10 printed without any error. Here we remove the value 5 from this variable var and insert the value 10 to this variable, so that's why we see 10 printed. You can also assign variable to variable instead of if you need to assign the same value to all variables. Like this. Int var1 is equal to 5. Suppose my new variable is var2. I declare and I initialize, or you can say I assign the value to it with the value of var1. Here you can see I am assigning the value 5 actually, because the value of var1 is 5, and assigning the variable to variable means assigning the value to that variable to another variable. Now let's print the value of var2 using printf function. As you can see, the output is printed as the value of var1. First, we initialize var1 and its value 5. After some words, we declare a new variable named var2. After that, we assign var1 to var2 and print the value of var2. Did you know, if you want to declare more than one similar data type variable, then instead of declaring separately, you can declare in a single line. This obviously decreases the length of the program like this. Int var1 equal to 5, comma var2 equal to 10, comma var3 equal to 15. Here, if you see carefully, we separate all variables with a comma and also declare more than one variable in a single line. This obviously decreases the length of the program. Now let's print all variables using printf function and after that run this program. As you can see, my output is printed with 5, 10 and 15. See this example. In this example, we print all values of variables using a single printf function. First, run this code and see what will happen. As you can see, the output is printed that we assign to these variables. Now, when the compiler comes to this line, after seeing the printf, it will go inside the double quote and see %d. It will go outside the double quote and search the first comma. After first comma, which variable name is present? In our case, we have a variable named var1. Now, it will go there where var1 is declared. Here is the place where var1 is declared and print the value of var1. After that, the compiler comes to this line again and now it will see a space. So it prints a space and see %t. Now it will search for the second comma because this is the second format specifier in this printf. Now here is the second comma. What is the name of variable after the second comma? var2. Where it is declared, it will go there and print the value of var2. Similarly for var3, and if we have more variables for all of those, the compiler will do same process again and again until all format specifiers will processed by the compiler. I hope this lecture is helpful for you. Thanks for watching and see you in the next one. Bye bye.